Everybody, and welcome to the water heating breakout session of the CalFlexHub Symposium. As a quick reminder, CalFlexHub is a Berkeley lab-led research project where we are developing, demonstrating, and deploying prices to devices-based controls and devices. These different controls and devices will receive prices representing different costs of operating the utility grid or carbon emissions at different times of day, and be able to automatically minimize the cost of operation given those different price schedules. Through this structure, we will be able to simultaneously support grid stability, enable increased penetration of renewables, and reduce utility bills for occupants. I'm Peter Grant from Lawrence Berkeley National Laboratory, where I perform research in advanced control of building technologies, primarily with a focus on residential water heating systems. And in this water heating breakout session, we have three great speakers for you here today, two of which are from academia, primarily the University of California at Davis, where they are focused on developing new technologies, which will soon provide more energy efficient and more load flexible operation in buildings. And we also have Tristan DeFrondeville from Skycentrics, who works in private industry, where he is working to implement advanced load shifting controls in the field every single day. Next slide, please, Anna. Okay, and as a quick introduction, just to talk about why water heating is so important for load flexibility. One of the key strengths of water heating is that it inherently contains storage and can therefore shift load without impacting the occupants. Heat pump water heaters typically have a 50 to 80 gallon storage tank, and so we can change the temperature of water in that storage tank to change how these devices consume electricity without the occupants ever even noticing. And this is an extremely powerful capability, especially when you notice, as shown on this plot, that water heating consumption loads very closely match up with both the morning and evening grid peak. And so we can leverage that storage capability to shift load away from those peaks by increasing the water temperature in the tank beforehand, and therefore both reduce the peaks and increase the renewable consumption during the midday period. Now, if you move over to the next slide, please, Anna. We see that the Rocky Mountain Institute has done a study evaluating the financial benefits and economic benefits of grid interactive water heaters. And there are a lot of details in the plot, but really the most important takeaway point is that sentence down at the bottom, where they estimated that if we can implement grid interactive water heating control technologies, the US economy can generate approximately $3.6 billion per year in value. That's incredible potential, and all three of our presenters today will be talking to you about what they are doing to help us achieve that potential. Could we move to the next slide, please, Anna? So our first presenter today will be Matt Ellis, who's an assistant professor with the University of California at Davis. And he's going to be talking about some controls that they are developing in collaboration with a manufacturer so that their devices will be able to ingest these prices and automatically operate in the lowest cost fashion. Take it away, Matt.
Yeah, thank you, Peter. Really excited to be here. My name is Matt Ellis, as Peter said. I'm an assistant professor here at UC Davis. So next slide, please. So this project that we've been working on with CalFlexHub is really a partnership between my research group here at Davis, as well as one of our centers, the Western Cooling Efficiency Center, WCEC. And Kate Manny of the WCEC is actually the PI in this particular project. So next slide. And what Peter sort of alluded to is what we're trying to do in this project is to develop a model predictive control strategy for residential heat pumps. So this control technology, why it's unique is it uses predictive models to predict load flexibility capability. And what that means is we can predict that load flexibility capability while maintaining occupant comfort for space conditioning, as well as meet occupant hot water demand for water heating. And it makes these control decisions really accounting for the future. We call this future period the prediction horizon. And this allows us to take proactive actions, accounting for the time variation of the real-time price signals, variations of weather over the course of the day, and grid greenhouse gas emissions. To the right, you see our project team. So as I said, this is really a partnership between my research group. We have a graduate student getting her PhD, really focused on aspects of this project, and Kate and Mandy of the Western Coulee Efficiency Center. And we have several folks from the WCC that are working on this project. We have several subcontractors. We subcontract with TRC engineers, WattTime, and then we have two partners that are affordable housing partners, including Mutual Housing and Quetzal Garden, and then a number of industrial partners. So next slide. Okay, so on the left, we show just a high-level view of our control approach. Really the sort of secret ingredient, well, it's not so secret, we publish on it, that allows us to develop these control strategies efficiently is the way that we represent energy systems. We do this in what's known as a graph. And the way that we're able to represent the systems enables us to instantiate or automatically instantiate the control problem, really alleviating some of the control engineering that needs to be done to develop these problems. And what's sort of unique, another unique factor about this control approach is it can account for a variety of different input data, and each one of these input data sources are shown in the circles on the top of the figure. To the right, we talk a little bit about what we're going to be doing in terms of testing and demonstration. So we've developed or really built a fully instrumented and identical heat pump water heater equipment setup in our lab. And we're able to replicate any load profile with flows from 0.01 to 9 GPM. Now it says here we're going to place it in our environmental chamber. This work has been done, and this enables us to tightly control the air temperature during any one of our tests and experiments with this experimental setup. For field demonstration, we're going to be applying this to 2 apartment complexes. And these apartment complexes are in partnership with our affordable housing partners, and they're located in the California Climate Zone 12 and California Climate Zone 4. So next slide. We've done some preliminary testing in simulations. So what we do is we built this high fidelity tank model that allows us to simulate the thermal dynamics of a heat pump water heater tank, really being able to simulate with high fidelity what goes on in that storage tank that Peter was talking about. And this enables us to simulate the entire closed loop process, gaining confidence that our control system would work. So this allows us to simulate the control itself, as well as call to the external data sources, which we call APIs, really collecting the data that we need for the demand response and pricing signals. And based on these early tests, we've shown significant reductions in the grid greenhouse gas emissions and costs, but certainly work is ongoing as we continue to refine the approach. And we're showing some examples that showed fairly significant reduction in the grid greenhouse gas emissions over a 24-hour period. So currently, our next steps really is to apply this to a lab setup so we can gain some confidence prior to making sure everything is working prior to going to the field demonstrations. So we should be completing these lab setup or lab tests in the next couple of months. So thank you. I think that's all I had to present, and I look forward to discussing more on the panel. Thank you.
Okay, excellent. Thank you for that presentation, Matt. And I'd really like to highlight that we're very excited about Matt's technology, partially because it is a very direct implementation of the prices to devices philosophy, which is a very streamlined and direct path to market for the CalFlexHub prices, and also because it's in collaboration with a manufacturer, which is a pretty direct path to products being installed out in the field. So the next project we have this morning is going to be presented by Subhrajit Chakraborty from, again, the University of California at Davis. He's a research and development engineer who is working again with a private company to develop an integrated heat pump system that has storage to provide domestic hot water and space conditioning at the same time. And one of the things that's very exciting about this approach is that by providing 3 services with 1 heat pump, we can reduce the cost of electrifying buildings because people only need 1 heat pump instead of 3. So we're very excited about this project, and over to you, Subhrajit.
All right, thanks, Peter. Thank you for setting the stage, Matt, on load flexible heat pump water heaters and space conditioning heat pumps. So this is another project from WCEC, Western Cooling Efficiency Center, in collaboration with Villara Corporation, where we are investigating the load flexibility of a new integrated heat pump technology that's being brought to the market by Villara. And this is, as Peter mentioned, it's 1 heat pump capable of multiple functions, such as the domestic hot water, space cooling, and space heating. Next slide. So this technology basically starts as like the core of it is the air-to-air heat pump, which can be easily retrofitted into a ducted household. So there are studies there that says that half of the homes in the US are predicted to need electric panel upgrades to electrify space heating and space conditioning and water heating. And electric service upgrades add cost and installation delays, which are a major barrier for low-income customers considering heat pumps. So this new air-to-air heat pump technology provides a solution. It's 1 efficient compressor and outdoor heat exchanger that provides an opportunity to electrify space conditioning and water heating, the 2 most highest loads of a residential buildings. The physical components of the system, as you can see, are the outdoor unit with the compressor, which replaces the one for an air conditioner in an existing household. It is connected with refrigerant lines to the air handler, most times in the attic, and the domestic hot water tank in a closet, which will be replacing a natural gas water heater in the same location. The controls components in this can be seen as the IHP board and the aquastat. The aquastat will be capable of remotely communicating the tank temperature, and the IHP mode, the heat pump can run in different modes to a cloud platform that we are developing. The cloud server will host the control algorithms. It will receive the price signals from various entities. It could be utilities. In this case, we are using the CalFlexHub price server. Take that information and use the algorithm to compute set points that will be communicated back to the smart thermostat and the aquastat. So the field site that's been chosen is a single family home of 2,000 square feet in Davis, California for this pilot study. Next slide, please. This, as from the left, you can see this installation of the domestic hot water tank in the same closet as pre-retrofit natural gas water heater. It sits in the conditioned space without inlet or exhaust air connections or any high voltage power outlet and our electric resistance heaters. So it's a big solution and opportunity to electrify households which currently have natural gas water heaters without making any major changes to the household. On the right, the plot shows an hourly average values during a 3-day period in September. On the left is the temperature. On the right are the run times, which are denoted by the bars at the bottom of different modes. Orange is the outdoor temperature here, and you can see that it fluctuates given the temperatures we saw during that 3-day period outside. And green, there is the water temperature, which is on the top of the tank, and it shows that it goes down with water draws and comes back up with water heating mode of the heat pump running. And the blue is the indoor temperature, which it can be seen as maintained pretty well during the summer condition by the integrated heat pump here. As on the bars denotes, they are the different modes that it is operating in the summer. The red bar shows the air conditioning mode. The purple bar is the domestic hot water heating mode. And you can see that it aligns with the water temperature going back up. And then we have the unique mode of simultaneous air conditioning and domestic hot water, which can provide hot water and cooling at the same time by taking the heat from the space and putting it into the hot water tank. There is, as can be seen here, the simultaneous modes are infrequent and lower run times. So there is a huge opportunity for us to use this mode with CalFlexHub controls that we are developing to leverage that and increase the run times of it and save energy. We have seen that this simultaneous mode has, and on average, have about 25% higher efficiency if we are to do the same loads in 2 separate modes of water heating and air conditioning. Next slide, please. So the core team here is myself on this project, and Dave Vernon and Timothy Levering. We also have a new person joining the team this week, Christy Green, helping us with load flexibility of this integrated heat pump. We also have Professor Matt Ellis and Caden Mann guiding us on controls and communication based on the learnings they have on the other project. So thank you for your time.
Okay, great. Thank you for that presentation, Subhrajit. And as I previously said, we're excited about Subhrajit's project because of the cost reduction implementations of a tri-gen system. But as you may have noticed during the presentation, there are also great synergies that drive efficiency here, right? It's entirely possible with that system to move the heat in your building when you're cooling the space into the water heater, so you can benefit from both sides of the vapor compression cycle. And at the same time, you can shift both loads. So this is extremely powerful, and we're very excited about this technology. As one quick logistics comment before moving into the final presentation, I would like to echo what Scott Cox already put in the chat window, and that's that we will have a breakout session after this seminar so that you can directly converse with the project participants. So if you have questions or comments, please bring them up at that time. And you can also enter them in the Q&A window now, just so that they have some time to think about it beforehand. For our third presentation, we have Tristan DeFrondeville, who is the CEO of Skycentrics. He'll be talking to us about how he is utilizing existing technology to shift loads with heat pump water heaters out in the field. And since this is using existing technology and this is already happening, I don't think I need to tell you why we're excited about that. So go for it, Tristan.
All right, thanks. Next slide. Yes, it's really exciting. This is just a slide that was asked to be put on. So that's our team. Thanks for that if you want to communicate to us. So yes, Washington State about 2 years ago passed a law that says every water heater in that state has to have an eco port so that we can scale communications to water heaters. That's really important because yesterday, very exciting, AHRI, a big manufacturer trade organization, said that every new water heater sold and made in the United States from 40 gallons to 119 gallons has to have the EcoPort. Energy Star will be joining. California has already a little bit of incentive for new construction. So it's super exciting that finally water heaters are going to have this very flexible communication path. So as you can see, we're using a cellular EcoPort CTA2045 module to get to the water heater. This is important initially because cellular is kind of more bomb-proof communication path, and you can imagine that when utilities want to send price signals, or the state, with the Midas server wants to send a price signal to a water heater, when you have 13 million California water heaters under management, they're literally helping you turn off large power plants. And obviously you need kind of a bomb-proof connection to that. Now down the road, as we develop other communication paths, it may be that things like FM radio or new paths that we haven't yet figured out will work. But in the short term, it really helps to have the two-way inexpensive cellular data providing an understanding of what's going on and a guarantee that that water heater is responding to the price signal. So we have translated the price signal to an action shape. And that action shape is essentially a set of commands that the water heater is used to taking. The water heater, through the EcoPort commands, there's 3 different levels of shed or turn off, 2 of which allow the water heater internally to have a smart response. And if it notices that it might have a cold water event, we don't want that. So it'll come on even though it's under event, asking it to use less energy. And then 2 levels of load up where it can use more energy. And oftentimes, no matter what, even if there's not negative pricing, which exists in a few places, when there's a lot of wind or solar, it allows you to load up and really make sure that the water heater is fully heated before you turn it off to support the grid. And because water heaters can store water, hot water for 8 hours, with all the new Energy Star installation in the last few years, that it's just basically a magic thermal battery for the grid. Next slide. So here are the standard pictures that you've seen. The blue is the TOU, a sort of a price shape, a simple one, right? You've got a high price of $1.75, a mid price of about 90 cents, and then a low price of about 40 cents. And a water heater, a heat pump water heater, is going to have a little bit more difficult time responding to all the orange hourly prices. So what we've done is, because heat pump water heaters like to be on for, certainly at least 5 or 10 minutes, if not 20 to 30 minutes, if not an hour. So we've digested the orange hourly price shapes and come up with bigger blocks of time where the water heater is on or off. So it's better than the time of use, which is a very blunt instrument, but it's not quite as wiggly as the orange line that you see here. Next slide, please. So one of the really important things to think about as we scale these solutions is, where is the schedule stored? Where is that action plan created and then stored? So eventually the water heater itself will be able to receive the price, create the action plan, and perform the action plan. That'll be great. In the short term, because that's a little bit hard, the action plan currently is created in our cloud. Eventually, the action plan could be created in our module, and then it could be also created in the water heater. And finally, once the action plan is created in our cloud, it's sent to the EcoPort. Now, this is really important, because if the communications between cloud and local building is cut off, you don't want the device, in this case a water heater, going back to random mode. That's the one thing that would be really bad. Imagine 13 million water heaters that are supporting the turning off of power plants are all being orchestrated to support things like we discussed. And then suddenly they get cut off of that signal and they go back to random mode. That would be very disruptive to the grid. So it's important that the schedule is stored at least in the module, the EcoPort module, if not in the water heater, so that at least it can respond to yesterday's schedule. If you look back at the pricing shapes that you'll see, it's going to be rare that it's really different every day. It's going to move things by a half hour or so, an hour to 2 hours even. But at least if you're turning off most of the time, that's going to be really important. So as we are all moving forward in this world of responsive electric loads, we want to make sure that the 24/7 schedule that repeats is stored either in a module or in the water heater locally. Next slide, please. So I've spoken to this. So next slide. So some of the things that are important to understand about the EcoPort is, number one, it allows the device to be smart, right? So it can load up before a shed. Historically, in the United States, 8 million water heaters have been under control for 40 years, but they've only had an external load control switch that cuts the power to the water heater. It has shown that for 40 years, there's a lot of value to managing water heaters, but it doesn't allow them to load up and be fully heated before the shed. Instead, they just turn off the power, and there's no, it could have been cooling all night, and therefore much higher chance of a cold water event. Also, there's no data being communicated back and forth. So you don't know if the water heater responded, you don't know if there was a cold water event. So big improvement on the smart loads. They also have the ability to do an advanced load up when a mixing valve's in place, so they can store even more energy. And finally, in the next version of CTA 2045, the water heater will be able to digest the price shape itself. But the most important part of the EcoPort is, if you count on manufacturers to provide one connectivity to historical electric loads that haven't had any. So remember, water heaters, you couldn't schedule them, at least thermostats, you could schedule them, and you could not communicate to them. If you ask an OEM to put in communications, they'll typically pick one to historical loads that haven't had any. They're only going to pick one, and it's usually going to be Wi-Fi. So having an EcoPort allows you to do flexible communication paths. Maybe you want cellular at the beginning to have inexpensive, guaranteed connectivity, but down the road, maybe an FM radio signal is good enough. So during this big transition for the next 5 years, it's super helpful to have flexible communication paths. The last story I want to say about the EcoPort that's really interesting is there was a company in the Midwest that wanted a switch that could go, that was an electric load switch like I described. And they wanted it to have cellular and Wi-Fi built in, but also an EcoPort. And I said, why do you want an EcoPort? You've already got cellular. That's the holy grail of connectivity. And they said, yes, but we want a 50-year piece of hardware. That's how we think as a utility. And we know that the 5G cellular that we put in now, in 10 years, it might not be supported. It'll be 10G, and then we can send a 10G module out and have it plugged into the EcoPort. So it future-proofs as well as communication path flexibility. Next slide, please. So I just wanted to show this slide. We created this. The bottom brown is the heat pump water heater turning on and off and how much power it uses. And you'll notice that, of course, as you would expect, it peaks in the morning after people take their showers, and it peaks again in the evening. It's a little bit more spread out in the evening as people wash dishes, wash clothes, maybe take a bath or a shower as well. But you can completely send that brown use of power of a water heater to zero during the critical times, because you can preheat it before those critical times and turn it completely off. So that's what's exciting about water heaters in particular. And we are putting these into Bay Area city buildings and fire station buildings. And we're also putting these into regular residential homes. And we will be testing all this coming up in January, February. So it's very exciting. Now, historically, Skycentrics has been doing it all over the United States. So we know this works. The big two new things are California, Bay Area, and changing the historical simple time of use shapes to more flexible, dynamic daily changes in the schedules. So we're excited to be doing that, and it'll be happening soon.
All right, thank you for that great presentation, Tristan. And as I'm sure you all saw, Tristan's doing great work on actually implementing these load shifting technologies out in the field using the currently existing CTA 2045 technology and communication signals. So it's, you know, I can't stress how valuable it is to have his input on all these projects as he's getting out there, you know, in the field doing this every day. So now we have 15 minutes of panel discussion before moving out to the breakout session. And there are some questions that we wanted to ask each of these presenters and participants today so that we can get their insights into where the industry is going and what the next steps for these technologies are. The first question that we have is, what are the technical challenges in developing these technologies? What hurdles do we still need to overcome? And Tristan, you look like you're ready to go on this one. Would you like to go first?
No, not too bad. The good news is, look, as I announced, AHRI and Energy Star are going with it. So every water heater in America is going to have this EcoPort. It's a very exciting time. So as far as water heater goes, great. I think it's worth me mentioning, especially for Subhajit, Matt, and others who are doing more commercial electric loads and water heating, that Skycentrics has developed a Sky Kit that enables it to give any commercial load that does Modbus, BACnet, 0 to 10 volt, or even just relays or MQTT, the ability to have a CTA 2045 port and open ADR certification sort of right out of the box. So super exciting to enable. We're working with a number of large OEMs in the commercial space to give them this easy alternate path to responding to grid signals rather than the historical BMS. Everybody should know that commercial buildings right now, less than 2% of commercial building equipment is connected to the internet to receive any signals. So it's a huge opportunity to take those larger commercial building loads and get them to be able to help the grid.
Okay, how about Subhajit next? What technical challenges do you need to work on in your Trigen system?
Yeah, I think as I was just describing, this is a new heat pump technology. It's a lot of complex modes in there, which will require some sophisticated controls. It's also an opportunity, as I had shown, that it allows for using those new modes to save energy and shift loads, shift two different types of loads. So as a technical challenge, that's what we are trying to head into and solve. On the other side of regulatory challenges, I would say there are no current standards or ratings available for this kind of combi systems. So that's something that we have to think about going forward. With electrification, how do we solve that? Like having a push in the AHRI or to come up with different ratings so that this type of combi systems could be rated and get into the market sooner.
Great, thank you. And Matt, what do you see as the next challenges to overcome in your advanced control strategy?
Yeah, I think so. The control strategy we're developing, it's called Model Predictive Control. It's been around for a number of years. You may have noticed that I'm a chemical engineer by trade, and the technology came out of the petrochemical industry. They've been using it with high success for a number of years. Still, the challenge really is deploying this thing at scale. It is a rigorous control strategy in the sense that it takes in all this data and then produces the optimal decision. The challenge with that is to do it across the many homes that you see across the California and the US. So we're doing a number of different technical things to help alleviate some of the challenges deploying at scale. I talked a little bit about the way that we represent systems. But I would say also as an educator here, it's training the workforce in these complex systems so that we can deploy them at scale. And so, not only do I work with a number of people from WCC, I actually train a lot of the folks. Subhajit actually is now one of my PhD students. So I think that there's also an educational component as well to train the future workforce.
Okay, great. And Matt, you actually touched on one of the next questions that we have in there. So I think I'll just direct the next question to you first. So what do you view as the role of workforce development for these innovations, and what efforts do you think we need to do to basically help make sure that these technologies can be installed effectively out in the field?
Yeah, speaking again as an educator here, I think these projects, it allows us to train students. Not only that, as part of their training, they're doing research that's sort of has real value, if you will. So one of my PhD students, Lauren Della Rosa, is actually getting trained as part of this project in other projects that we're working on. And so these projects like this are vital because we have to fund these students, vital for the workforce development. So I don't know, did that answer your question? Can you remind me what the question was, Peter? Did I get to it all?
I think you covered it. Yeah,
Okay,
the question was just, what do we need to do to help make sure people know how to install these technologies effectively?
Yeah. So I think the name of the game is things are moving to more complexity, and so training students that are capable of addressing these systems engineering challenges, I think is important for future success.
Mm-hmm. Thank you very much. And Superjeet, same question to you. And I know your system will be a bit different from a traditional HVAC system, so you might have some comments here.
For sure, yeah. There is I would say, notch for like going to a combi system here for training and getting the workforce ready. But I totally echo what Matt was just saying, is that the information, that very academic information that Matt and I'll be studying and looking at, needs to be some way drilled down into the people who are going to be implementing the system, the manufacturers who are going to be building these systems. We are working with them, and then the contractors which are going to install the system, and then customers at the end point where they need to be aware to be able to sign up for this kind of systems where they're comfortable with like this automated control of the systems with with the price response. And as far as this system that I just mentioned, the integrated heat pump, there is obviously the challenge of educating like even researchers who are been working on just heat pumps, but this ability to connect all the components of a system through one compressor, that's new, and that's needs to be another learning curve for them. I would mention that for like this kind of air-to-air heat systems, the change is a little less drastic than the air-to-water heat pumps that are coming into the market now. So, but this will kind of pave the way for those air-to-water systems that are heat pumps that are coming into the market and needs installation and workforce development.
Okay, and Tristan, you're muted if you're trying to talk to us. Okay, yeah, so Tristan had to step out for a minute. He's answering questions. So I can provide quick 2 cents on the workforce development needs for his technology, just based on my knowledge of the product. And it's a pretty simple product that he's using. The CTA 2045 module is a simple little device, and heat pump water heaters are now in many states and soon nationwide required by law to accept them. So he actually has a training video on his website where he shows himself attaching the device to the water heater and then screwing in 2 bolts. So, contractors will need some level of training in order to learn how to do this, but that's not a huge barrier. And we think that's one that could be overcome without too much effort. So the third question that I want to ask before moving out to the breakout discussion session is about the business strategies and route to market adoption. And so I'm wondering, what are the key strategies for scaling and promoting market adoption of your technology? Does this involve different business models? Do you need to get different stakeholders or code involved? How do you see this being adopted by the market? Superjeet, would you like to go first?
Sure. As I had mentioned, I think I touched on this a bit on the technical challenges, but yeah, it's more of a, as you mentioned, strategy and market adoption. It's very key that regulators look into standards, look into this combi systems and develop rating standards, because now the heat pumps are not just going to be dependent on outdoor temperatures and conditions because it's air to air heat pump. It's also because there will be the hot water piece there where you're doing combined loads. So the temperature of hot water also plays a role in the efficiency and all that. As a strategy, I would say when you're looking at going into the market, the biggest benefit of this system is, as I had mentioned, go into retrofit homes where there are limitations on electric service and panel upgrades. And this system has the potential to not eliminate electric resistance heaters and just operate on just that one compressor piece and provide space cooling, heating, and water heating without requiring any upgrades to the household electric service. So.
Thank you, Subhajit. And Matt, since you're partnering with a manufacturer to change their control logic, I imagine you have a pretty straightforward path to market. But what do you think about that question?
Yeah, I mean, we certainly have partners that could take this forward as we transfer the technology from us to them at towards the end of the project. But I would say that the migration towards more dynamic pricing is going to create more of a need for the technology that we're working on, because the idea here is to respond without sacrificing comfort, right? And that's going to be that's what we're really being able to deliver, is to be able to save money without sacrificing anything is a sort of a win-win. So I think that one of the drivers here that I see as pulling this need is more on the migration to the dynamic pricing. And then the other thing I wanted to say is towards the end of the project, even though we have a partner and do plan on transferring our code to that partner, our code is open source, and we have a number of folks interested in taking that forward, and we even have ideas on how manufacturers can provide their secret sauce. And so we're happy to talk to other potential partners.
Excellent. And I see we're very short on time, so I'll make this the last question. But Tristan, you're already out in the market. You already have insights into what's limiting adoption. What do you think we need to do to increase the size of this market?
Well, what's super exciting on the residential side, every water heater is going to have the EcoPort. So it's just a question of figuring out the right way to have these new heat pump water heaters go into place. In California, what's exciting is 120 volt heat pump water heaters have been developed now that can just plug into the wall, no panel upgrades. So that's super exciting. They become a little harder to do grid control with, right? Because they don't heat up as fast, but that's exciting. I think taking advantage of the fact that every water heater is going to have the EcoPort now, super exciting. And finally, in cycle 2, little hint, right? We're doing large multifamily electric water heaters as the first big commercial load, because multifamily, same residential load profile of the morning peak, the evening peak, and if you can totally shut that off. So we've already done 100 apartment building in Seattle for 2 years, shown how it's perfect. It literally completely turns off at the times you want to support the grid. And there's 5 or 6 of those being installed in California in the next 2 months, and we're hoping to bring those into the CalFlexHub. So, there's going to be, this is a big thing that's going to happen that everybody's been working towards, and it just needs a little regulatory help, a little incentive help.